So we're now going to be looking at extending our ability to sketch a trig function, so specifically cos and sine, by actually being able to label our x values or our intercepts as well. So we're going to focus we won't focus exclusively on radians only, but we will be doing a majority of the work in radians, and then we'll just convert the radians values into degrees, because later on we do basically just focus on radians when we are sketching trig functions. So if we look at the following question we've been asked to sketch y equals 2 cos of x. So what I would start by doing is identifying what the graph actually looks like. So we know a cos graph will look something like this, and we know that we have an amplitude. So I'm just going to write amp of 2. So that means a maximum y value of 2 and a minimum y value of negative 2. Now, another thing we have is we've been given our domain. So we need to actually work out, well, how many cycles do we have for this particular function in this domain? So we know in order to work out our period, the rule is 2 pi divided by n, and n is the coefficient of the x term. So in this case, n is 1. So our period for this particular graph is 2 pi. So what that means is that it will basically go for one rotation, and we should be anticipating 2 x-intercepts. Now, in the previous video, I did mention the fact that we have 2 x-intercepts, but I didn't actually explain why. So I thought I might do that now, just so you can sort of make the connection between everything we've done so far. So if we take a look at our unit circle here, so I'm just going to quickly fill in the information. All right, so what we can see here, or what we know, is that we have the following properties in each quadrant, so that all are positive in the first, sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. Now, if we take a look at the properties of the unit circle, like I said, cos is positive in the first quadrant and in the fourth quadrant. So what that tells us is that our 2 x-intercepts can be found using these properties here. So now if I have a go at drawing my axes, so what my cos graph will look like is something like this, and that will be one full cycle. So what this means is that my y-intercept here will be 0, positive 2, and my ending value here will be 2 pi 2. And the reason for that is we know that the distance between the two peaks will be the period. And we know the period here is 2 pi. Now, what you might be wondering is, well, how are we going to find out the value of the trough, or the minimum value here, or even just the x-intercepts? So what we know about this particular graph is that it is symmetrical. So given that there have been no other transformations that have happened to this particular graph, we can say that that is pi and the y value is negative 2. But we can't always rely on intuition to help us find the coordinate of the minimum value. So here, another thing you can do, we know that the minimum value will be negative 2, and we know that because of our amplitude. So what you can do is some algebra here. So we can do negative 2 instead of y is equal to 2 cos of x. Dividing out the 2, both sides, we get cos of x is equal to negative 1. And if we do the inverse of cos, like so, of negative 1, x is actually equal to pi. And if we think about the unit circle and why that is, we know that x is negative 1 where it's pi. Therefore, when the inverse of cos is negative 1, x is equal to pi. That's how we get our minimum value, or our x minimum value, to be pi. Now, if you're wondering how we're going to find our x-intercepts, we can do something similar. So here we can say cos of x is equal to 0. Now here, 2 cos of x is equal to 0. So again, we know cos of x is equal to 0 divided by 2, which is going to be 0. So the inverse of cos of 0 will be 0 and 2 pi. And the reason for that being, will be pi on 2 and 3 pi on 2. And if we take a look at our unit circle again, if we think about where cos is, remember cos is the x-axis. So cos is 0 at pi on 2, and it's also 0 at 3 pi divided by 2. So therefore our two x values will be pi divided by 2, and here it'll be 3 pi divided by 2, 0. Now, if this graph had a period that continued, so just do it in a different color. So if it was continuous, then we would know the distance between this value here and that value there will be 1 period, so we would add 2 pi. This value here and this value here will have a distance of 1 period. And this coordinate there to that coordinate, assuming that the axis continued, would be a distance of 1 period as well. And that's it for this particular graph. So I did ask for you to sketch it from 0 to 360. So what we can do here is we can just draw up a quick sketch. So again, here we know that that is going to be 0, 2. And instead of 2 pi here, that's going to be 360 degrees and 2. Now instead of that being pi, that'll be 180 negative 2. This value here will be 90 degrees, 0. And this coordinate here will be 270 degrees, 0. So now if we move on, we've got another function where we've been asked to sketch it, and this time we're sketching y equals 2 times sine of x for a domain of 0 to 2 pi. Now, this particular graph, with a sine graph anyway, we know that it looks something like this. Again, no other transformations have happened, so we can expect it to look something like this. We have been given a domain of 0 to 2 pi, so that's going to be how many cycles? Or we need to work out how many cycles, sorry. So we need to work out our period. So here our period is going to be 2 pi divided by n. N is the coefficient of the x term, so that'll be 2 pi divided by 1, which is 2 pi. Now we've got an amplitude as well here, an amplitude of 2, which means my minimum y value is negative 2 and my maximum y value is positive 2. Given that we have a period of 2 pi, we're also going to anticipate 1 cycle only, so it's exactly like what I've sketched here. So I'm going to draw up my sketch now, or my proper sketch anyway. And remember, my domain is restricted from when x is 0 to 2 pi, so that's all I'm going to sketch, which is exactly 1 cycle. So here I'm going to label what I know, which is that the graph started at 0, 0, and it ended right there at 2 pi, or when x is 2 pi. But now what about the rest of this graph? So in terms of labeling what we don't know, we need to have a look at labeling our maximum, our minimum, and even our x-intercept here. So with the sine graph, given that there have been no transformations happening, we can actually work out that this value here is pi 0. Now the reason for that, if we solve this trig function, so we know that y is 0, what we didn't know what x was. So 0 equals 2 sine of x. So we're solving for x in this case. 0 divided by 2, is sine of x. So the inverse of sine of 0 is equal to pi. Now, if you think about the unit circle here, right, so here, sine is obviously our y-axis. So for sine to be 0 would be just there. It'd also be at the start of our unit circle and at the end. Hence why it's 0, pi, and 2 pi. So those are the 3 points on this graph that coincide with our unit circle. So now, one of the beauties of the sine graph is that everything is quite symmetrical. So the distance between 0 and pi, if we halve that, we can actually get the x value of our maximum. So another way we can do that is we know that our maximum y value is 2, or it has to be 2, because we know that given the amplitude. So what we can do is we can say 2 equals 2 times sine of x. Now 2 divided by 2 equals sine of x. Sine of inverse 1 equals x. X is equal to pi on 2. And we know that by looking at our unit circle again, when sine or the y has a value of 1, it's at pi on 2. Now looking at our minimum value, again we know the y component will be -2 for this particular coordinate. So what we can do is do exactly the same. So -2 equals 2 sine of x. So we've got sine of inverse 1, -1 equals x. X is equal to 3 pi on 2. Now, if you throw this into your calculator, you might actually get an answer of -pi on 2. And the reason for that is if we drew, or if we made this continuous going backwards this time, the calculator will actually find this value here. And that's only if you haven't restricted your domain. Now, if that's the case, and looking at our domain, we're told it only is valid between 0 and 2 pi, we know we can't accept this. This is why I've drawn it in a dotted pink line. All we have to do is add a period. And in this case, our period was 2 pi, and that'll get us to this value here, which is 3 pi divided by 2. However, if you are asked to sketch it and I've specifically given you a domain of 0 to 2 pi, please make sure you don't actually sketch what I've done in pink, because otherwise your graph will be incorrect. Now, I've also asked you to sketch this graph in degrees as well, so that's from 0 to 360. The graph itself will look identical to what we've just sketched. All that'll be different is obviously our values, so instead of them being in radians, they're going to be in degrees. So we'll have a graph that looks something like this. That's y, that's x, and that's going to be 360 degrees. This here will be 270. And that's it for sketching trigonometric functions using our ability to now solve trig functions too. So what you can see is now we're combining the skills together in order to complete our understanding or our ability to sketch basic sine and cosine graphs.